All right, since I know everyone is here paying attention and everyone here actually wants to be here because they're not playing with other stuff right now. So let's see. So class.
Yes.
Yeah. Thank you. Thank you. See what I did there? Okay. What are you supposed to be doing? Not that. Thank you. All right. So these is actually going to be a quick set of notes. There is a whole lot of. Where's my stick? Oh, blade. There you go. Okay. So. Okay. So where's that other stuff go? We'll wait for now because it's going to be a quick set of notes, right? I know you got this stuff in your lap. Okay. But if I see that again, it might make me do my recycling. My recycling is shredded daily. Where's that going? Oh, wait a minute. So if I see it out, it's going to be shredded. Then you're really not going to get much done after that. And yes, I am keeping this part in my video. So everyone knows I'm yelling at Blade. Anyway, all right, continuity. So let me give you the entire definition of continuity in one thing. For it to be continuous at a point, the left side, right side have to be equal, and the function also has to be equal there. So it has to go, so if the left side and right side goes to an open dot, that is not continuous. If the left side and right side both go to different places, guess what? That's not continuous. Okay? Think of it as a roller coaster. Anyone actually been on a roller coaster? Yeah. Anyone actually find a roller coaster that is not continuous? No. Because a roller coaster should be continuous, right? So, in that track for that roller coaster, are you going to find any holes? No, hope not. Okay. In that track for a roller coaster, are you going to find a jump? What would jump be? The limit? Yeah, they both go to different places, right? That's important. So, let's go through this. All right. Continuity, add a number. Definition of continuity, add a number. Function is continuous, add a number if the following three conditions are met. It is defined, and that C is in the domain of F. It is possibly continuous on something that is a function that, let's say, an ln. ln does not exist beyond 0, or to the left of 0. It doesn't. There's no graph there. But I can still say it's continuous from, let's say, to the right of 0 on to positive infinity. The limit of C exists. So that means both left side and right side have to go to the same number. And the limit is equal to the function. So the left side and right side go to the number, so that means the limit exists, and that limit is equal to f of that number. So they are both going to a closed dot in between. Left side and right side are both going to a closed dot. Okay, that would be this as the example. Left side and right side both go to the same number, and it's equal to the function. This one, left side and right side go to the same number, but if you guys can see it here, that spot right there, it's an open. So that means that roller coaster has a hole, but it is right there. It's equal to there. So that means it's not equal to the function. This one right here, it is open there, but it's undefined. So right there, there's no place that is. So there is no closed dot on that spot. Yes. What? It's right there. What package? Oh, racket. Can you wait till after the notes? Because, like I said, it's going to be quick. Stay. No. Pay attention. Anyway. So, limit as it goes to the left side, goes to here, right side goes to here, and the function is equal to here. All three of those are not equal, because all three have to be equal. This right here, same thing, goes here, but it's f of c is undefined right there. So the only good one is there. All three things have to happen. The function has to be equal to it. What do you mean? Yeah, this is for a function, so yes. All right, determine whether this is continuous at 1. Okay. Is there any holes in that one right there? No holes, no undefined, right? Okay, so just looking at the problem, I'm not going to find anything undefined. So therefore, it must be, now, can I plug in at 1? Yes, I can plug in at 1. So if I plug into 1, I should get 3 minus 5 plus 4. Which is going to give me a grand total of 2. So, the function, so f of 2, I'm sorry, f of 1, sorry, wrong number. F of 1 equals 2. I don't have any place in which there's going to be undefined over that, so that must be fine. I don't have anything. So yeah, that one's going to be okay. Now, determine whether this one right here is going to be continuous at 2. So, can I plug in 2? Why? I hear yeah, I hear no. Why is it going to be undefined? Okay. So that would give me 0 in the denominator, right? So on this graph right here, if I look at it, I'm going to have x squared plus 9 over x plus 2, x minus 2. So, zero product rule. Anything times 0 is 0. So, is 2 going to make one of these become a 0? Yes. So that would make 0. So anything times 0 is 0. So that means that if I plug in 2, it would be undefined. So G of 2 is undefined. So if it's undefined, is it continuous? No, it's not continuous. Does that make sense? No, that is not. Just like you have an imaginary track on that roller coaster. You hope the engineer decided that he's not going to use imaginary track, right? So that would be a no-go. All right. Hello, who's it today? Let's see. We have 1. We have Blaine. We have Angela Ramirez, or unheaded, sorry. And we have Victor. Shayla. Nathan. Joseph. Karen. Tree. All right. So, this one right here, let's take a look at this, please. Now, this one right here is going to be the square root, which is going to give me some restrictions, but is there any restrictions on that one? Is there any restrictions on the numerator? What? For this one right here, this one particular. Can't be negative, right? Okay, but look closely at that. What is that square going to do? Makes it positive, so no matter what number I plug in, this is going to be a positive number, right? So, it's always going to be positive. So I don't have any restrictions on the numerator here. Okay? So, no restrictions. Denominator. Denominator right there. I'm factoring it. Can I plug in -2? So f of plug in -2, right here, I would get 0 for this first part. So if I get 0 for that first part, that's 0 in the denominator, so therefore that part is going to be undefined. F of +2. If I plug in +2 right here, what's going to happen? Is that also going to be undefined? That one also is going to be undefined. F of 0. F of 0. Plug in 0, what do I get? 0 is going to give me rad 2 over 0, -4. That's a -4. Okay. Is that a number? Yes, it is. So does that one exist? So is there an f of c that exists there? There is an f of c that exists there. And if I were to go through and look at my graph on this, I could see that it is going to be undefined here, but between those two, it is continuous. Between those two, it's going to be continuous. So this part right here is going to be continuous at 0. Because for it to be continuous, the left side and right side both have to go to that same number. So at 0, the left side and right side of the function is going to go to 0. Does that make sense? Questions, concerns, complaints, conspiracy theories? Okay. I don't know if this is a conspiracy, but have you heard the one where Texas just recently banned fake food, or lab-grown meat, but Arizona has not. So, in a petri dish, you're putting it in a baggie, putting in the biological materials, and hope it grows to give you a chicken breast. But is that really vegan if it's not really alive? But if it doesn't have a face, okay, so it does that really. So here's the graph that we're talking about. So at -2, +2, right here, I'm going to have a vertical asymptote at both of those, but in between there, so it is continuous from here to here. Who had 24? Anyone have 24? All right. Everyone was voting on no confidence. All right. Let's see if it is continuous. So left side and right side have to go to the same number. Let's start off by just plugging in. Can I plug in 3 into that one? So this is called a removable discontinuity. I can't plug in 3 directly. Why can I not plug in 3 directly? I heard it, what? Okay, it's going to be undefined, but we're going to have the top, which is x plus 3, x minus 3, over. So this is the first top, the top of it right there. Cancel those out. Now can I plug in 3? If I plug in 3, what is this function going to be going to? Yep, it's going to be going to 6. So x at 3 is just 9. Now this one over here, can I plug in 3 on the right-hand side? 3 squared is 9 minus 3. So if I were to graph this, it would look like this side goes to 6. This goes to 6, which would go something like this. And so open dot here. Right side also goes to 6. Right here. And at 3, something like that. So, if I'm on a roller coaster and I look at this thing, did you grab the notes from up here? If I'm on a roller coaster, do you want this to be a roller coaster? Hell no, right? So, is that continuous? Nope. Removable discontinuity. That's what I just did right here. It leaves me a hole. Let function be defined everywhere on an open interval containing C except possibly at C. The number C is called a removable discontinuity if the function is discontinuous at C but the limit exists. The discontinuity is removed by defining or redefining the value of f at C to be the limit. Visually, the graphical function f is a removable discontinuity, has a hole, like I said, hole, that's the key word, hole. Everyone say it with me? One more time. It is called a, thank you, if we could remove the discontinuity. Okay, for this discontinuity removal, because we could fill in the hole by approachingly defining f, the function will then be continuous at x equals c. Yes, Becca. Okay, so now, for it to be continuous, all three things have to happen. Okay, left side, right side, and f of c is equal to the limit. Okay? If it's discontinuous, okay, no, the limit still can exist. So, back to my sketch. Does this limit right here exist? For the limit to exist, you need your left side and right side to go to the same number, right? Okay. So the limit exists, but it doesn't mean it's continuous. Does that make sense? Just like all thumbs are fingers, but not all fingers are thumbs. Okay? But if I were to go back the other way and say, hey, if something is continuous, what can you assume? That the limit exists. You could assume the limit exists because it's continuous. But if the limit exists, can you assume that it is continuous? No. That's where it is right there. So that's perfect. Good job. And we got there the whole. Okay, we just did this one right here. Oh, floor function. Take out your calculator. Someone actually left the calculator up here to charge. I don't know who that was. Some weirdo. So, I know everyone's doing this on calculator because you probably have never even seen a floor function before. And have no clue how to enter a floor function. So, this is key, because you're going to see this. It's weird. Go here. Got my graph. Now, you notice it looks kind of like an absolute value, right? But it has feet, didn't it? It has feet on it. Go right here. Bam. Do I see it there? No, I don't see it there. So I'm going to have to go a little bit further. So I am going to open up the book. The book has everything else. The book has everything else. So these are all my symbols. Let's see what 5 has. 5 has the same thing that I had in that last one. Okay? So that's what that shortcut is leading us to this one right here. All right, let's go over here. So, number. Don't get so mad if I can't find it. Okay, I'm so mad now. All right. All right. T. So start with F. Four. There we go. So I had to go all the way to the book. Okay, so okay, let's start over again. You guys ready? You guys ready? You ready? Are you paying attention? Are you ready? I'm going to hit escape. Now you ready? Book. I'm looking under the book, option 1. I type the letter F, and then I just hit down. There's 4. I know it's in one of these special, like, areas. I don't know where it's at anymore. Because it used to be in that first thing, but they update the software. Floor. And the floor function, was it just X? Okay, type in X. And there you go. Now, this is what a floor function is. A floor is going to round it down all the way until you get to the next number. So if I have the right here, so if I go 0.1, it's a floor, and it stays at 0. It rounds down to 0. 0.1, 0.2, 0.3, 0.4, 0.5, all the way till I get to 1. When I get to 1, this becomes an open dot, and up here becomes a closed dot. So when I get to 1, then it is equal to 1. So it rounds off whatever decimal you have down to 0 until you make it to the next one. Huh? Nope. That's why it's called the floor. There's another one which is a ceiling function, which actually, instead of having like little hands going like this, it has hands going like this. Okay, then you go like this. Okay, so how'd you go there? How'd you go there? How'd you go? Anyway. Hell no. You really think I want to put this? I'm already World Star famous. I don't think I need any more. So there it is. Here's what the graph looks like. So now you guys know how to find floor, because you have a couple of these in the homework, even at some point. Yeah. Okay, so now all the way, so it's all the way to here, but once it gets to 1, it, okay, when it gets to 1, then it is a solid number up here. Yeah? All right. So that being said, here's your definition, so you guys have these. I need to do this next one. continuous and continuous and continuous. Theorem, theorem, theorem. Here we go. IVT. This is going to come up forever. Forever. This is on your AP calculus exam. This is also on just about everything. Intermediate value theorem. This is what you're going to write down on this slide. Did the chicken cross the road? Seriously. Did the chicken cross the road? You're writing this down. Why would I have you guys write down something so stupid? It's funny for me. Like, now, you're asking a question. There's a chicken. It's sitting on the side of the road. You see the chicken. You know that the chicken started on that same side. Okay, I need 2 volunteers up here. 2 volunteers. Come on up, come on up. You're chicken 1. Okay, you're chicken 1. You ready? Get over here, chicken. Okay, now I got 2 chickens here. Ready? So, did the chicken cross the road? So, now, we walk up to this point right here, and we see. We started off with, because right now we went to the road, we're at the convenience store, we're going to go get our, our 99-cent slushies. Okay? At this point right now, I see 2 chickens, 1 on either side of the road, right? After I come out of the store, this is what I see. Can I prove that this chicken right here crossed the road? Why? Hey, it's still crossing. It's still crossing. Because now you're on the other side, right? But we saw at the beginning who was on this side, right? Now, can we prove that this chicken right here crossed the road? No. Could have this chicken right here cross the road. Okay, how? Why cross and come back, right? But mathematically, we cannot prove it by looking at my end result. So quite possibly, this chicken crossed over here while you're getting that slushie, and then crossed back. So can we prove? We cannot prove that this chicken right here crossed the road. Can we prove that this chicken here crossed the road? Yeah. That's the whole intermediate value theorem. Did the chicken cross the road? I just summed up the entire math concept with 1 chicken cross the road joke. Make sense? Okay, good. All right. Now, in this right here, here is an example. Okay, let f be a function that is continuous on a closed interval from a to b, and f of a is not equal to f of b. That means that with both sides, so you can't say your end result is the same side of the road. That's what that means. If n is any number between f of a and f of b, then there is at least one number, c, on the open interval where f of t is equal to n. Now, right, so right here, starting elevation, this hiker is at 2,000 meters. Ending elevation is 5,000 meters. No matter how many ups and downs you take as you climb, at some point your altitude must have crossed this. This is the road. Did they cross the road? Okay, I could prove it because we started down here, we ended up here. Quite possibly, could the road have wiggled? Could they have started here and ended up like that? Yes. We don't know how many times they crossed the road. but we know they cross the road at least one time. Does that make sense? Okay, good. So, use intermediate value theorem to show that has a 0 between 1 and 2. So, first, I am a moron. I ended up getting caught up. So, sorry. No, I do not. I'm still a moron, though. Like 10 more minutes, I'll be done with the notes and I'll print it, okay? All right. Thank you. All right, so let's start with the start would be 1. Let's see, what is f of 1? 1 plus 1 minus 1 minus 2. Negative 1. F of 2. 2 to the third power is 8 plus 2 squared is minus 2 minus 2. I get 8. Where is the road in this conversation? Where's the road? It's at 0. Has a 0. That's important. Has a 0. Sometimes it's not 0, but most of the time when we're talking about this, we're referring to it crossing the 0. Yeah. So that means that f of some number, so f of c has to equal 0 between my ends. So we're looking at the question. We started at negative 1. We ended at 8. Did the chicken cross the road here? Yes, because I started at a negative, ended at a positive, so therefore it must have crossed 0 somewhere in between there. Wait, no, yeah, that's all it is. We're asking the question, did the chicken cross the road? Yes. So if it was a negative over here, negative 8, we can't say yes. It might have, but we can't say yes. No. No. This one is asking for a 0.
Okay, but if it wasn't, it could be between two negatives. It could start on
Yeah. See this right here? We have 2 positives in this problem right here, right? So my start was at 2,000. My road is at 3,065.6, and my end is at 5,000. There we go. So yeah, the road's in between those two, right? There we go. Yes, it will say where is it crossing, or does it cross this number? Okay, or it gets crazy. If you're not fluffing your freaking hair on your phone right now, you bet. Oh, sweet baby Jesus. All right. So okay, like this. Is it possible, not on this one right here, so it is possible, so if I start off at 1 being right here is negative 1, that right here, I start, 2 is at 8, which would be way up here, here's my 0 that I'm looking for, that's my line, that's my road, because you're going to see some that's going to be like this, and it's going to tell you it crosses more than once. Is it possible to have that? So I could tell you that this crosses how many times? So let's say I give you and I give you a problem that's something like this. I'm going to say, hey, it's here, start is here, end is here. It crosses 3 times. Draw a graph. It crosses 3 times. Draw a graph. 1, 2, 3. What if I had another one? It said crosses twice. What would it look like if it said cross twice? Let's say I start off right here. That I'm starting at here, and I'm ending at here, and crosses twice. So I know it will cross and has to come back down, right? That's what that would look like. So I'm telling you, I'm foreshadowing that you're going to have problems like this. All right, I think that's it. Yep. Make sure you guys all like, share, subscribe, hit that notification button, support my channel, buy stuff from my merch store. There you go. Work on your homework.